Good day, dear colleagues. My name is Tron. Today I would like to present the results on formation of the separation characteristic of ore material thickening based on the model predictive control method. Optimization of the technological line of ore beneficiation requires determination of a resultant separation characteristic with the operating point within optimal separation limit. Yet, in flow of raw materials of the ore processing line, significantly different varieties of raw ore as for their mineralogical, physical, chemical and mechanical characteristics can be processed at different stages. Therefore, it's necessary to study calculation parameters of the separation characteristic of the technological process of ore processing, in particular ore raw material thickening, based on operational information about dynamic of their parameters. The results of the analysis of the scientific research and practical developments have shown that application of the ultrasonic method of thickening in developing of automated control of ore raw material thickening requires additional research. This research is aimed at development a method of automated control of ore raw material thickening to optimize a separation characteristic of this technological process when concentrating several mineral technological varieties of ore based on the model predictive control method. An example of comparing the useful component content in a certain grain size class to the yield of this class distributed along the technological line of beneficiation provided on this slide. The values of separation points of the first sizing stage at the data of experimental studies are presented in table. On figure it's shown separation characteristic of sizing unit of technological line at ore beneficiation plant. Parametric models in table are evaluated by the following indicators. The sum of squares due to error, the closer to zero the value obtained is, the smaller value of the random error component is. This indicating high accuracy of the model. The multiple coefficient of the determination, R square, indicates what fraction of a result dispersion is caused by the influence of the independent variables. This indicator is determined as the ratio of the sum of regression squares, SRS, and the total sum of squares, TSS. The control of the thickening process is formed using the method of the model predictive control. On the basis of this model predictive control scheme, the influence of values of the control horizon and the prediction horizon on control quality on the thickening process is investigated. The duration of the control intervals is assumed to be equal to 1 minute. The simulation results for the different control and prediction horizons are presented on the next slide. Total results of calculating control's quality indicators of iron ore thickening and set value of the control horizon and the prediction horizon are presented in this table. The obtained results allow concluding that when forming model predictive control for a single channel control system of the thickening process, the control horizon is equal to 1 interval is sufficient. For this value, the quadratic error varies in the 1.4 or 0.14. Further, to increase in the prediction horizon does not significantly reduce the quadratic control error. Yet the value of 3 to 5 intervals will be sufficient for the prediction horizon, as increased computational complexity of the prediction by 10 20 intervals lead to a slight decrease in the quadratic control error. Thus, to form separation characteristic of or material thickening process based on the model predictive control method for a single channel control system, satisfactory control results are provided by the setting the control horizon equal to 1 interval with the prediction horizon of 3-5 intervals. Further research is aimed at studying the possibility of controlling the thickening process as a multidimensional object of these variable parameters, considering in particular changes in characteristic of minerals and technological varieties of processed iron ore. Thank you very much for your attention.